All right. So for this afternoon, we'll be discussing about differential amplifiers. And our first experiment using MATLAB Simulink is also using differential amplifiers. So for this afternoon, I would like to explain to you the concept, the principle behind differential amplifier. So basically, a differential amplifier is an electronic circuit that amplifies the difference between the two input signals while rejecting any common signals that are present in both inputs. So always consider that you have two input signals, and then from the difference of these two input signals, you needed to amplify. In simple terms, it focuses on amplifying the changes or the variations between the two input signals while ignoring what stays the same in both signals. So these are some of the factors, characteristics that we needed to consider. First yung inputs. For the inputs, meron tayong tinatawag na inverting terminal and non-inverting terminal. So the inverting terminal or the inverting input is represented by the negative sign, and the other side, the non-inverting input, is represented by the positive signal. The inverting input is connected to the inverting terminal of the amplifier, and the non-inverting input is connected to the non-inverting terminal as well. So in terms of the differential and common mode signals, the signals applied to the inverting and non-inverting inputs are often referred to as the differential input signals. The amplifier amplifies the voltage difference between these two inputs. So later on, we'll be watching another video showing us how do we get the difference between the two input voltages. So there is another aspect known as the common mode signals, which are signals that appear at both inputs with the same amplitude and phase. So take note, I highlighted here some of the important parameters that we needed to consider when amplifying the signal, the amplitude and the phase. The goal of a differential amplifier is to reject or minimize the amplification of these common mode signals. So what is now amplification? So basically, the main function of a differential amplifier, as mentioned earlier, is to amplify the voltage difference between the inverting and the non-inverting inputs. The gain of the amplifier is determined by the characteristics of the circuit components. The output voltage is the amplified difference between the voltages applied to the inverting and the non-inverting inputs. In terms of the differential gain and the common mode rejection ratio, or the CMRR, differential gain is the amplification of the voltage difference between the two inputs, while the CMRR, or the common mode rejection ratio, typically measures how effectively the amplifier rejects common mode signals. So take note, in terms of relationship, the higher CMRR, the better, kasi it indicates better rejection of the unwanted common signals. So we needed to get higher values for the CMRR. So for the symbol and configuration, the symbol for a differential amplifier is often drawn with two input terminals and one output terminal. So later on, I'll be showing to you the symbol for the differential amplifier using MATLAB Simulink. It can be implemented using various configurations, such as the long-tailed pair or the operational amplifier, or also known as op-amp based differential amplifier. So what are the applications of this differential amplifier? So basically, these are used in electronic circuits, especially in applications where the difference between the two signals needs to be extracted or needed to be amplified, and common noise needs to be rejected. So lagi naman ganon. So we always wanted to reduce the unwanted signals or the noise. They are commonly used in instrumentation amplifiers, communication systems, audio processing, and many other electronic devices. So for our summary, a differential amplifier is a crucial component in electronic circuits that focuses on amplifying the difference between two input signals while minimizing the impact of common signals shared between the inputs.